example number 2 is one of those ones where you have to be able to do an error analysis and kind of see where somebody else might do something maybe a little different from you. Okay, you have to determine if it is an actual mistake or if it was just a different technique, and then like find out what their error is. So here's the example. Leo is solving this rational equation and his work is shown below. Okay, guys, did it show the step where where we discovered our common denominator and then we put a wavy line through the common denominator and said thank you very much? Okay, that step is missing, okay, but it's not a mistake. Okay, it's just that they just simplified a little bit. So just make sure when you're doing your error analysis that it indeed is an actual mistake and not just like they just skipped a step. Okay, skipping a step isn't a mistake unless they really miss something up. Okay, so my suggestion is that you do the example beside and then you just compare it to the student's work. Okay, so what we've been taught, okay, is like what I've been teaching you is first we're going to factor the denominators. Okay, so I have 1 over x minus 1 is equal to 4, okay, x minus 1. Okay, then we did a common denominator. So in this case, okay, x times x minus 1 is our common denominator, so we just need an x on this side and an x on this side. Once our common denominators are the same for an equation, we can say, okay, thank you very much to our denominator, and we're just focusing on our numerator. Okay, so we have x is equal to 4. Okay, so what the other student did, okay, they did, do you guys remember, okay, back in junior high, do you remember doing cross multiplication?
Yes.
A little bit. You've heard of it. Maybe you don't remember how to do it. Okay, I'm just going to, yeah, it's been so long. Okay, I'm just going to move that up a little bit. All right, fresh sheet. Okay, here's what it looked like. It was like, Okay, so guys, I'm doing one that you can kind of visualize and know what x is going to be before we even do the cross multiplication, because you're going to tell me, well, x is equal to 1. Okay, I'm going to show you what cross multiplication looks like is we just go across the equal sign and we multiply those together. So the 10 gets multiplied by the x, the 2 gets multiplied by the 5. Okay, then we isolate for x. Okay, we divide both sides by 10. 10 over 10 is 1. Okay, that's what cross multiplication looks like. So in our question, so this is a technique that you might, the reason I'm introducing this is because you might see a question like this, oh, I was going to say on your diploma, okay, on a test, okay. We do common denominators just to stay consistent. Another technique or another strategy is to do cross multiplication. So I just wanted to explain what you're seeing in this question, okay, but we're actually not going to be, okay, doing a lot of cross multiplication because when we do common denominators, that will work in every single situation, whether or not you can use cross multiplication or not. Okay, but so what's happening is, okay, they went and did 4x minus 1. Actually, here, let me put this one on the side first. They did this, x squared minus x, okay, and they did that all times 1. And then they did this one, 4 times x minus 1. Okay, so if you're following along in your notes, okay, this is what you can see in their step 1. Oh, sorry. Where's my notes? Oh, up here. There, sorry, couldn't find my notes. There we go. Okay, so this is a cross multiplication that happened. So this, guys, is actually, this is fine. This was a technique that they use, cross multiplication. A little different from ours, but that's okay. Okay, and then, okay, then they multiplied through, okay, and got x squared minus x, 4x minus 4. Okay, this step is correct. Okay, then they just subtracted 4x, so we got 5x, that's fine. Added 4 to each side. Okay, added 4, so to get this, they got to this point. Guys, we used the quadratic formula to solve for this. Do you remember in grade 10 doing product sum as one of the factoring things? Where we said like two numbers to multiply to get this number, add to get that one. Okay, that's what this guy did. Okay, so they did two numbers to multiply to get 4 and add to get -5. Okay, so they actually factored this way. Okay, and then and then they got their solution. Okay, x is equal to 1, x is equal to 4. Okay, and so then they said they had this. Now, okay, we did this, okay, and we got one solution, whereas Leo got two solutions. Okay, so, and it says Leo's answer is not correct. Explain the error in his work. Okay, what's one thing we haven't yet talked about that we always talk about when we do rational expressions? What about the non-permissible values? Okay, did we do NPVs? No, we did not. Okay, so we have to, and guys, this is why factoring the denominator and not doing cross multiplication is always going to get you the right answer. Because when we factored the denominator, we got our NPVs. Okay, we said x cannot equal 0, x cannot equal 1. There we go, x cannot equal 0, x cannot equal 1. Okay, and our x cannot equal 1, okay, that ended up, okay, not being used. And so here, the reason why Leo's solution to the equation is because he listed x is equal to 1. He didn't check it against the NPVs. Okay, and so explain the error in his work. Okay, so Leo forgot to include the NPVs. Okay, which are, okay, which would make x equals 1 extraneous, right? Not part of the solution. Okay, so that's the error in the work. So sometimes they'll have a question where there isn't actually a mistake in what they did. It's the solution that they didn't check it against the NPVs. Okay. Okay, so then we're going to head back to what we were doing yesterday, where we were creating common denominators. Okay, remember, we have an equal sign, so that means we actually get to solve for x now. Okay, so the first thing we're going to look at is we're going to say, okay, do we need to factor our denominators? Done. State NPVs. Okay, what can x not equal? 0. Okay, then we're going to do common denominators. Okay, what's my denominator with a 4? Yeah, we can always put it on over 1. Same with the 6. Okay, guys, don't forget that step because it needs a common denominator. Okay, so that means that if our common denominator is x, the 4 is missing the x on the bottom, so we have to multiply 4 over 1, okay, times x on top and x on bottom. Okay, I've noticed some of you guys, they aren't writing exactly what I'm writing, which is okay. I'm not going to make you, but some of you are just writing like that common denominator. You're just kind of like writing it once and not writing it top and bottom. Okay? You will lose marks on a written response question if you're doing, here's what I'm talking about. Okay? Let's say you had this where it was 1 over x plus 3 minus 2 over x minus 1. Okay? I've seen some people kind of doing 1 over x plus 3. And they're kind of like, there's an x minus 1 with this one. And then there's x plus 3 with this one. And you're not writing it twice. You do. Okay, you have to. Because, okay, because this, guys, this is not equivalent. I like totally, like mathematically, like I get in your brain, this is just like a little step, and like you get what you're doing, and your next, okay, the next part is fine. But mathematically, this is not equivalent. You're changing the question. You have to show that you understand that when you multiply top and bottom, you're just multiplying the question by 1. So you're not actually changing the question mathematically when you multiply by 1. Okay? So don't try to take shortcuts in this area. Show me top and bottom. Okay? Because there's a difference in the denominator and the numerator. Okay? So back to this guy, show top and bottom. Plus 2 over x is equal to 6x times x plus 3 over x. Okay? Once everything is over the same common denominator, thank you very much. You've done your job. Okay, and now we have 4x plus 2 is equal to 6x plus 3. Okay, when we have 1x, okay, we can just isolate for x and solve. So x on one side, everything else on the other side. Okay, so we could go minus 6x, minus 6x. Okay, we're going to subtract 2 on this side, subtract 2 on that side. So we end up with negative 2x is equal to 3 minus 2 is 1. So we divide by negative 2, divide by negative 2. X is equal to negative 1 over 2. X cannot equal 0. Okay, there's one solution for this. Okay, when you have just a single x, there's always going to be one solution. When we have an x squared, okay, there could be 2 solutions. There could be 1 solution, or every once in a while there could be 0 solutions based on our non-permissible values. Okay, so let's do the second one. If you're feeling good, I want you to like start doing this one, right? Work ahead. If you need to, you can follow along. Okay, but you guys have all the skills that you need in order to do B. Okay. Yeah. Yeah, be quick. When he's back. Okay. So first step, we check for factoring. Second step, non-permissible values. X can equal 4. Third step, common denominator. So everything was common except the 2 didn't have anything. So we had to multiply top and bottom by our common denominator of x minus 4. Okay. Once everything has our common denominator, thank you very much. It's done its job. Okay. And then need an equal sign on over here. All right. Then I'm going to distribute. Okay, collect like terms. 5x plus 2x minus 8 is equal to 3x plus 8. Let's get x's on one side, all the numbers on the other side. Okay, so I have 5 plus 2 is 7, minus 3 gives me 4x. And then 8 plus 8 is 16. I'm going to divide both sides by 4. X is equal to 4. Okay, guys, my non-permissible value is x cannot equal 4. Well, I just said my solution was 4. So this is an example of, yeah. Okay, this is extraneous. Okay, so you guys use this. the little triangle, like the little 3 dots, to mean therefore. Have you done that in science? Okay, that's what that means. Therefore, there's no solution. Okay, so this is an example where you got a solution, but then when you checked it against your NPV, okay, extraneous, I'm just going to write like a note to self, because like if you're wondering why we crossed it off, okay, it's extraneous because of the NPV. That's why you always have to check. Okay, we'll do this. We'll do one more in our notes. Okay, then we'll do some board work. Okay, no, we're going to do this one in our notes. Okay, so first thing you're going to do, you're going to factor. You're going to find your NPVs. You're going to do your common denominator. Okay. Okay, so hopefully you saw the difference of squares when you factored it. Okay, your NPVs, x cannot equal plus or minus 2. Common denominator, this one has the plus 2, it just needs the x minus 2. Okay, guys, top and bottom. This one has the x minus 2, it just needs the x plus 2. Okay, top and bottom. Once you have your common denominator, thank you very much. So now we can distribute through our brackets, 3x minus 6. Guys, okay, just be paying attention to the signs, okay? It's a subtraction, so we have to take the negative 5 through the brackets. Minus 5x minus 10 is equal to 2. Negative 2x, okay? We have minus 16, we're going to add 16 to both sides. Gives us 18, divide by negative 2. So yes, x is equal to negative 9, and we double checked. X cannot equal the plus or minus 2. So again, we have one solution. All right, let's head to the boards and do number D. Yeah, we do number D. Oh, and I had a request that you guys work on the window on the inside, okay? Because it was just too noisy in the hall.
Yeah, we're a little noisy.
Yeah. All right, for those tuning in from home, we did some board work on D, so I'm just writing out the solution here. You can see that it turns into a quadratic, so we had to use the quadratic formula in order to solve it. And going all the way down, we had 2 solutions. However, when we checked with our NPVs, one was extraneous. So our answer is x is equal to 1 because x cannot equal 0 or 3. Okay, you can pause this to write down and complete your notes. Now we're working on practice questions.